So we're going to be simplifying rational expressions to start. Remember, rational expressions are expressions that have a polynomial on top and a polynomial on the bottom. It's a fraction. A rational is a fraction. It actually has the word ratio in it, because a ratio is when you divide two numbers. You compare two numbers by division. So that's what we're doing here. A rational expression. There is some exclusions that we are going to talk about, but for the first one, let's just go over how you would simplify this. We've got x squared plus 7x over x squared. Can we simplify it? Have we done this before? You've done it already.
Yeah.
Brandon, what do you get?
What?
You know how to simplify it? If I multiply what by the reciprocal? What's the reciprocal? Okay, so this is what I wanted somebody to say, so I could tell you, no, it doesn't work. You cannot do this. Is that what you're saying to do? You cannot do this. You know what happens if you do that?
That's fine.
You cannot cancel out. Let me show you an example of why you can't do that with numbers that would make more sense to you. If I had 4 plus 7 over 4, what would that equal? What on top? 11 over 4. Is that the same thing as 7?
No.
So that is not something we're allowed to do. Because order of operations says you have to add together before you divide, and we can't add those together, so you cannot divide. But what you can do, here's another old-time example of what you learned a very long time ago. If we had something like 8 divided by 24. You had something like 8 divided by 24. You are allowed to do what to that? Reduce it. How do you reduce that?
Just divide by 8.
What you're actually doing is you're taking 1 times 8 over 3 times 8. And you're canceling the 8s. So you're allowed to cancel if it's multiplication. You're not allowed to cancel if it's next to addition. So in order to cancel things, you have to factor them first. Factor means unmultiply. You have to factor before you can cancel. So our first step for this is factor. So in our numerator, how do we factor x squared plus 7x? What's our first step of factoring always? What's our first step of factoring?
GCF.
Find the GCF. What's the GCF? So we take out x, and we have left over x plus 7 over. How do we factor x squared? How do you unmultiply x squared? And then from there, we can cancel out the x and the x because it's being multiplied. We're allowed to cancel it. So we get x plus 7 over x. And that is our x. Oh wait, can I cancel the x over the x?
No.
No. Do it. So the next one. What should we do first? Well, that is the first step of doing what? Factoring. So what we should do first is we should factor it. Is there a GCF?
No.
No. So how do I factor 3 terms? Guess and check. So you say what multiplies together to give you negative 12, but adds together to give you negative 4.
Negative 6.
And on the bottom, how do you factor 2 terms?
X minus 2.
Well, you just killed a puppy. How do you factor 2 terms? Out.
Say
squares.
Difference of squares. So difference of squares only works when it's subtracting two perfect squares. So we get x minus 2 and x plus 2, difference of squares. After you have it factored now, can we cancel anything? So we get x minus 6 over x minus 2. What? Yeah, can I cancel out the x? Can I reduce the 6 and the 2? No, because of the subtraction signs we can't. But there is something else here that we have to include. So what we are saying by writing this answer is we are saying that the original expression is exactly equal to this expression, but it's not. There's something that is different about the two of them. You are telling me by putting an equal sign that they are completely equal. So what I'm going to do to show you that they are not actually equal at this moment is I have put this equation into my calculator, and you don't need to do it. I'm just going to show you on the screen. I put this equation in my calculator, and I put this equation in my calculator so we can compare their values. So I went to y equals, and I put in the first equation, and then I put in the last expression on equation, to see if they are equal. And I'm going to go to my table so I can look at the values. And when I look at the values, the x's are all the same. The y1s and the y2s, are they all the same? They're not all the same. Why does one of them have an error and one of them have a value at x equals -2? So what happened was originally the equation had an x minus 2 and an x plus 2 in the denominator. And if there is a number in the denominator that equals 0, we get the error message. That's why there's an error. So originally we had an x minus 2 in the denominator and x plus 2 in the denominator. If I set that equal to 0, and I solve it for x, I see that x can't be 2 and x cannot be -2. Just like how we found the domain on last night's assignment. It's the exact same way. Remember, the denominator can't equal 0. That was in the domain. That was the asymptote, right? So we have 2 asymptotes for this one, but this one we only have 1 asymptote. So when that happens, when you cancel out one of those asymptotes, when you cancel out one of them, you have to write that as part of your answer, saying these 2 equations are completely equal with the exception of x cannot equal -2. Because at -2, they're not equal. At -2, this one doesn't have an asymptote where this one did. Yes?
Basically, you have to put it in your calculator and find what you don't have to.
No, it's what you canceled out.
That's what you can. Oh, okay.
So what we're trying to do, I wanted to show you on the calculator, so I guess if you're stuck, you could certainly try that. But I wanted to show you why they're not equal. But up here, when I look here, and originally I had 2 things in the denominator, now I only have 1 thing in the denominator, something's changed. And what changed? It was the one that I canceled out. Okay, so you're going to see that in all of the examples that we do today. So hopefully after the 6th and 7th example, then you'll be like, okay, now I get it. After the first example, maybe not. It's going to be a process where you are actively learning as we do it together. So here's our next example. What should be our first step? Factor. And the first step of factoring is factor out a GCF. Is there one?
Yeah, no.
Nope. So then we have to factor the numerator and the denominator separate. So let's look at our numerator. How do we factor x to the 4th minus 16? What's it called? What's it called, the factoring? Difference of squares. Good. So x squared plus 4 and x squared minus 4. difference of squares. Should we factor it further?
Yeah.
What factors further? All of it? Just the difference of squares factors further. So yeah, let's factor that a little bit further. I'll just cross that out and I'll write it right above it. X plus 2 and x minus 2. So that part factored further. Now is it factored all the way? On top.
Yeah, on the top, yeah.
So on the bottom, we have 4 terms. And this one I know we haven't factored in a while. How do you factor 4 terms?
No, it's, gosh.
What?
Yeah.
What? I didn't hear.
It's like the.
Nobody remembers, huh? It's called factor by grouping.
I think that's what.
Oh, okay. So we're gonna put our groups in. I knew we had to go over that one. Oh, don't worry, there's another one I'm sure you've forgotten about too. Factor by grouping, we're gonna do what to the first group?
No, X squared.
So take out the GCF of the first group and we get 5x minus 3 left over. And then the second group, what's the GCF? 4. And then we have 5x minus 3 left over. The parentheses have to match if you're doing factor by grouping. So we factor out that parenthesis that matches, we make it into one parenthesis, 5x minus 3. And then the other parenthesis is what's left over, x squared plus 4. So that's factor by grouping. And what do we do? Cancel it. Cancel out your x squared plus 4. Does anything else cancel? Okay. So we are going to get on top x plus 2, x minus 2, on the bottom 5x minus 3. Then we have to see if there's any exclusions, because we canceled something out that was in the denominator originally. Originally in the denominator, we had an x squared plus 4. When is x squared plus 4 equal to 0? What do I do? So is it ever really equal to 0? No, it's not. So this one actually doesn't have any exclusions because the one thing we canceled out is can never equal 0. So we don't have any. That's going to be the toughest part, is that exclusion part. Next one. So what's our first step? Factor it. It's already factored. So let's just start canceling stuff. And we get 2 over x plus 3. And then we see if there were any exclusions. Was there something that I canceled that could make the denominator 0? So that means I have an exclusion where x cannot equal -1. How about number 2? What do we do first? Factor. How about the denominator? Is anything factored out of the denominator? I don't know what you said, I'm sorry. Huh? On the bottom, difference of squares? Not on the top. On the bottom, difference of squares? So in the denominator, difference of squares gets us x plus 4 and x minus 4. Now what do we do? Okay, so I'm going to cancel those out. But what do I get left left over on top?
0.
No!
1.
When we cancel, it's division. So if I divide out this number, there's still something holding its place. Another way you could think about it is I could have done a GCF for x plus 4. It would have been a 1. So I get 1 over x minus 4. Are there any exclusions? Is there anything I canceled that's not in the original or in the final answer? So I write x plus 4 equals 0 to figure out what x cannot equal. What can x not equal? Number 3. What should we do first? Huh? What should we do first? Try to do what? We're going to try to factor it. That looks like it's already factored. So then what do I do?
Just try the team.
Huh?
Oh, no. But it's not even.
There's nothing defined where it's not equal to because we didn't change it at all. It's only when you change the equation that you do that. So this one's already simplified. You don't have to do anything to it. How about number 4? What do we do first?
GCF.
Is there a GCF?
Not GCF.
Well, GCF is factored.
You know that.
I just want you to know what you mean. So on top, we're going to factor by guess and check. On the bottom, we're going to factor by guess and check. Don't yell it out. Just give everybody a moment to try it on their own. See if they can guess and check their own. We're going to do it, so. Factoring was from a long time ago, I know. But we have been doing it here and there. So 2 times 1 is my negative 3. We've got to multiply together to get the outside number. Add to give you the inside number. So negative 3. How do I multiply to give me negative 3, but add to give me negative 2?
Negative 3, positive 3.
How do I multiply together to give me negative 6,
Negative 3.
but adds to give me negative 1? So we get x minus 3's to cancel. We have x plus 1 over x plus 2 with a restriction where x does not equal what number?
3.
Positive
Positive.
3. Yep.
Oh my gosh.
That sounded very, like you were super excited to start this one. Okay, this one, now we're doing multiplication. And we have to know how to multiply fractions by hand because, like, when you look at this, there's no way you're typing that in your calculator. You can't. So you have to know how to multiply fractions. How do you multiply fractions?
You add the exponents.
That is not answering what I'm asking. How do you multiply fractions? Straight across. You're answering a different question than I'm going to ask anyway. Straight across is how you multiply fractions. So we're going to take whatever you see and go straight across. So I'm going to have 8. I'm going to have that multiplied by 7, which eventually I might multiply together, just not yet, just so you know. And then we have an x to the 3rd and an x to the 4th. And when you multiply them, you do what to their exponents, Brandon? You add them. So we have x to the 7th. Then we have y to the 1st and y to the 3rd. So we have y to the 4th. So again, you have to know the stuff we did before to be able to do this stuff. Then we have 2 times 4 times, how many x's? 1 times how many y's?
Wait. Any subtract those.
Okay. Yes, do it right on your paper. I did that last class and I confused some people. So when we did this before, when we subtracted our exponents before, that is the exact same thing as what we are doing today, where we're canceling stuff out. It's the exact same thing when you subtract the exponents, or you like cross stuff out that's on the top and the bottom. As long as it's all multiplication, it's the exact same thing as what we did before. So if you're going to subtract your exponents, how many y's am I going to have left over?
Oh, because that's what.
How many x's am I going to have left over?
6.
Okay. I'm going to show you the way the book shows it, which, then don't look. Which is, when I did it in the other class, like, they needed me to show the book way. So, by the way, is there anybody that will argue with me that this doesn't happen? What I just cancel out? 8 with, okay, so that cancels out. 7 doesn't cancel out with anything. So I have 7, and then if I wanted to write this factored, do not have to do it this way. If you want to write it factored, you'd have to write like
Jesus.
okay. I would not do it this way. I'm just showing you why it works. And then we can cancel 1 of the x's and 3 of the y's. So what do we have left over on the top?
X6.
What do we have left over on the bottom? Not nothing. We have 1 left over, so we don't have to write it. So if you just subtracted your exponents and put x to the 6 on top, and you subtract your exponents, you put y, that's totally fine. That's how I expect you to do it. But people were confused by that, so we did that in the other class. All right, now, are there any restrictions? There are restrictions. There are exclusions, I mean, exclusions. So how you know that there are exclusions is if there was something in the denominator that got canceled that could make the denominator 0. You see how here the denominator has variables, here the denominator has no variables. So it canceled out. What would make this 0 if I plugged in what number? Okay, so x cannot equal 0. What would make that 0? Or that 0? Or that 0? So you have to say that x is not equal to 0 and y is not equal to 0. Because that is different from the original. Okay? All right, another multiplication. We're going to start by factoring, but we're just going to go ahead and do the multiplication at the same time, because you multiply straight across. You basically take out the times symbol and write one really big line. Multiply straight across. And I already know that this one has a trick to it, so as we're factoring, I'm going to factor that one last on purpose, because I already know it has a trick to it. You may not realize it. I'm just going to factor that one last. Maybe we'll just do it together. Whatever. I'm just going to do it in a different color. Let's factor that one. How do I factor?
Divide by 3 and create a GCF.
GCF? What is a GCF? 3x. And then what are we left over with?
X.
1 minus x. Okay, how about the one underneath it? Factor that one. We've got guess and check.
X plus 5.
X plus 5 and x minus 1. This one on top, guess and check. X plus 5, x minus 4. And then the one on the bottom, we factor 3x. Just 3 times x. Okay. Now, why did I put the one in green in green? Why did I put it different? Aaron?
You factor out the variance, cancel with the variance.
So I heard half a way said, I'm sorry, I'm just kind of here. I heard you factor out 3x and then I
You factor out the 3x in the numerator, so then it's considered a 3 context in the denominator.
Uh-huh.
Cancel it out.
Well, why did I put that one in green? Special for a different reason. Those 3x's are going to cancel, but that's not why I put it in green. There's something else. Are you guys looking? Like, imagine what you'd cancel there. You see those? They're not going to cancel, but they're so close. They're not going to cancel, but they're so close. X has to be first. Right. X has to be first. So, no, you can't do that. What would have been better is if I had known this ahead of time, and now I know it, I can fix it. If I had just reordered this to start, so I have the x coming first, if I reordered this to start, I'm going to rewrite this as negative 3x squared plus 3x. I'm just going to reorder that. You see how I just took the negative and I put it first? So no, it didn't change the value, I just changed the order of it. And then if I have a negative first, what should I be factoring out? I'm going to take out a negative 3x. And when I take out a negative 3x from negative 3x squared, just x is left over. When I take out a negative 3x from a positive 3x, what do I get? Negative 1. So taking out that negative helps me switch the signs so that I can cancel the x minus 1s. So that happens to you if you have the signs completely switched and you want to cancel it, then you just have to take out a negative number when you take out whatever you're taking out. You have to factor out a negative number. We did do this before a long time ago. The x plus 5s also cancel. Aaron, the 3x is still canceled, but there's something still left out in front. A negative what?
1.
Negative 1. So we get negative parenthesis x minus 4. Or you can rewrite it, if you would like, as negative x
Plus 4.
plus 4. We have restrictions, because there was stuff that we canceled out that is no longer in the denominator. So what did we cancel out from the denominator that is no longer in the denominator? X cannot equal what? Negative 5. Or positive 1. And there's one more. Or 0. If x is by itself, then x cannot equal 0. So that would be our final answer. We got one more we have to get through. Okay. First step. Factor. Is there a GCF?
Yeah.
What?
Always one.
For any of them?
On the right side, actually on the bottom.
Okay, remember, I don't want to assume anybody remembers this, but remember if it's just like a whole polynomial by itself, it's over 1. So when we multiply straight across, that goes to the top only. When we multiply straight across, that goes to the top only. And then on the bottom, how do I factor that?
X minus 3.
No. But you are on the right track. That is a difference of cubes. Let's go over that formula, which we probably have forgotten since we haven't done it since we factored. So the formula, I am giving you the plus formula, but it works for the minus formula also. You do the cube root of each term, and then the second parenthesis, you square the first term, You subtract the two terms multiplied together, then you square the last term. Yeah, you have to put in numbers.
No, I don't understand.
Right, because we have done this before, but if you don't practice things or you don't do your assignments, you forget things easily. So we are going to factor. The first part is just going to be the cube root of x cubed and the cube root of negative 27. So we're going to have x, and then we're going to have a minus 3. So you cube root the x cubed, and then the minus 27. Then you use those numbers for the second part. The first term is you square this first term. So we get what? X squared. The last term is you square the last term. Square it. Square this whole term. Positive 9. The middle term is that you do minus the two numbers multiplied together, which is plus 3x. Ooh, isn't that convenient? If you look right above it, isn't that convenient how it came out? Yeah. And I usually do stuff like that, so you help you out a little bit. So we have x plus 2 over x minus 3. And when we did cubes before, when we were factoring, this second part doesn't factor further. When we were doing cubes, we had talked about how the second part of the trinomial never factors further. If we tried to solve it, it would have to be with the quadratic formula and be imaginary. So the good thing is there's no exclusions, because this would be imaginary answers. So there's no exclusions with that one. Okay, turn the page. I want you to pick any of those 3 questions. 5, 6, or 7. The top one would be, the top one, if you felt like that one was confusing when we did that example, do that one. If you felt like you need practice on the cubes, do the last one. Don't pick the easiest one, pick the one that's most challenging so that you feel good about going into the homework. You feel like you know what you're doing. I am putting the answers up, so whatever one you choose, you can check it or ask a question if you got it wrong. Your work and my work might not be completely exactly the same, but our answers should be. If you can. If you're that fast, do all 3. Okay, reduce it. Don't divide it, reduce it. What can you factor out of the top and the bottom? Okay, so factor out that 3. What else can you factor? Okay, so that 4 is correct, except for, where's the bigger number? So it should be still in the denominator. It doesn't all of a sudden move up, it's still down there. So the way I did it is I multiplied 3 times 6 together. You see I have an 18 up there. And then on the bottom, I was like, ooh, 8 is divisible by 2, and so is 18. So I took 18 and I split it to 2 times 9, and then I canceled that 9 up on the bottom too. You didn't have to do it that way. That's the way I did it. I'm going to put the assignment up on the board so that you make sure you have it before you leave. It is in the book, and remember the book is on Big Ideas if you don't have it at home. It is just the stuff that we learned in class today. Do not take a picture of them standing up here. Let me pause the video first, then you can take a picture.